Good afternoon, students. Last class we started concentration terms. In that concentration terms, we discussed mass percentage, volume percentage, mass by volume percentage, mole fraction, molality, and molarity. So I think we are in molarity in the last class. Once open your notes and check. So total 5 concentrations we completed in the last class. And do I thought that relation between molality and mole fraction of solute also we completed, I think so. Right. Now write molarity. So are you following, students, everyone? So today I am going to start with molarity. Do I started that molarity? I didn't recollect. Even then once again continuity. Right, heading molarity. So molarity is shown by the symbol capital M. Then what is molarity? The number of moles of solute present in 1 liter of solution. So definition of molarity is the number of moles of solute present in 1 liter of solution. Understood? Saw the difference between molality and molarity. Molality is weight of solvent in kg. Here volume of solution in liter. 1 liter of solution. Understood? And this molarity is mathematically shown by number of moles of solute upon volume of solution in liters. So this is the relation for molarity. The molarity is given by number of moles of solute by volume of solution in liter. Place this relation in the box. Now, what is the unit for molarity? Units for molarity, if you see, it will be capital M we represent. Capital M means molar, or we can even write mole per liter. Mole per liter. This is the unit for molarity. Now, molarity will be temperature dependent or temperature independent? As there is volume term here, so temperature will have influence on molarity. Right, it is temperature dependent. Up to this understood, all of you? Copy this. And mathematically we can even write this molarity as small n upon V. What is small n here? Number of moles. V is volume of solution in liter. Clear, students? Simple. This is what molarity. And units, if they ask, its unit will be capital M, or we even say mole per liter. And it is temperature dependent. Copied, all of you? Now see, then how we get number of moles? Number of moles, in 11th we get mass by molar mass. So in place of moles, in the problem they don't give moles directly. If they give mass, what you do? Convert the mass in moles. How? Copied, everyone? See, in the relation, see in the above relation, I can write mass of solute by molar mass of solute into 1 by volume of solution in liters. This is the relation when we expand the above equation. Now question, in the problem they give you mass of solute to you. and volume of solution will be given, provided if it is in liter, then we apply this relation. Molar mass we can find out from the substance. Clear, student? This is important relation from molarity. Numerical problem we get from this. Suppose if the volume of the solution is given in milliliter, then as you know 1 liter is how many ml? 1000 ml. Then you have to take the relation molarity is equal to mass of solute upon molar mass of solute, that is molecular mass of solute into 1000 upon volume of solution in liter. This is the relation. When do we take this relation? If the volume of the solution is given in milliliter. Here it should be milliliter. Understood? This is another relation. When we apply this relation, if volume is given in milliliter. Clear, students? This is what molarity. Now see, in exam they are using terminology, might be you know in 11th standard, decimolar. What is meant by decimolar? Deci means 0.1 molar, 1 by 10. Sometimes they give in textbooks like this 10, m upon 10. Decimolar. It is understood, decimolar. Semimolar. What is semi? Semi means half. Semimolar is to be taken 0.5 molar. That is sometimes they showed in textbooks like this m by 2. Decamolar. Deca means how much, students? Deca is 10 molar. And centimolar. What is centi? Centimolar is 1 by 100. That is m by 100, or we can even write 0.01 molar. So these terms you have to know, you know prefixes deci, semi, deca, centi, millimolar. If millimolar is said, what is milli? 10 power minus 3. That is m by 1000. That comes 10 power minus 3. That is 0.001 molar. Copy these relations, and these terms you have to know. In exam they use the terminology deci, deca, semi, milli. Understood, students? Are you following, everyone? So simple. This is what molarity. Now write one question related on molarity. Copied all of you. So these two relations are important. Now write one question on molarity. Find the molarity of 40% W by V NaOH solution. Copy this question. Question understood what I am asking? What will be the molarity of 40% W by V? What is W by V, students? Mass by volume percent of caustic soda solution. NaOH is called what? A caustic soda. Now tell me, student, what does 40% W by V mean? 40 grams of NaOH is present in 100 ml of solution. No? Do you agree? What does 40% W by V mean? 40 grams of this solute is present in 100 ml of solution. Now we want molarity. We know the mass, we know the volume of solution. So direct we can substitute. Molarity is equal to mass is given 40. What is the molar mass of NaOH? You have to be thorough with atomic mass. Sodium is 23, oxygen is 16, hydrogen 1. When you add 23 plus 1, 24, 24 plus 16, that comes 40. So 40 upon 40 into volume is not given in liter, it is given in milliliter. So I have to convert this 100 by 1000, 1000 goes to numerator. Then 0, 0 get cancelled. These two zeros get cancelled. 40, 40 get cancelled. So what should be the molarity? 10 molar. It is a decamolar, we say. Understood, students? Simple this is. This is how we find the molarity of solution. Clear? So 40% mass by volume means 40 grams of NaOH is present in 100 ml of solution. This terminology you have to understand, mass by volume percent. Now write next question. Find the molarity of when 6.02 into 10 power 20 molecules of urea. What is the formula of urea? NH2CONH2. This is an organic compound. You study later in organic chemistry. So these many molecules of urea present in 250 ml solution. Question you understood. See, when question is given, understand, write data. What he wants to find, what will be the molarity when these many molecules. What are the molecules given? 6.02 into 10 power 20 molecules of urea. It has been present in 250 ml of solution. So what will be its final molarity is asking. Now students, you have to recollect what is molarity. Molarity is nothing but number of moles present in volume of solution in liter. But had he given to you number of moles directly to you? No, no. So what he has given? Molecules given. You have to bring the molecules in terms of moles. In 11th class you are familiar mole concept. So are you getting idea? If I take 1 mole of urea, in 1 mole of urea, how many molecules will be there means Avogadro number of molecules, correct? Are you getting my point? In 1 mole urea, 11th mole concept, you people are familiar, no? In this, how many molecules will be there? 6.02 into 10 power 23 molecules of urea will be present. So if 1 mole is having these many molecules, in the question he has given how many molecules to us? To have 6.02 into 10 power 20 molecules, then how many moles does it weigh? So cross multiply 6.02 into 10 power 20. This is divided by 6.02 into 10 power 23. Now both will get cancelled. 10 power 23 bring numerator. Minus 23 plus 20. That comes how much? 10 power minus 3. These many what we got? Moles we got. Now moles we found from the given data, molecules we converted into moles. So here I have to substitute 10 power minus 3. Volume is to be present in liter, but he has given in milliliter. So then what will be molarity? Molarity is equal to the moles what we got here. I am substituting 10 power minus 3 by volume is being given 250. So this 250 I am dividing with 1000. 1000 goes in numerator. So this 10 power minus 3, 10 power 3 get cancelled. Then what is left? 1 by 250 will be remaining. Now when you simplify 1 upon 250, how much you get? 250 upon 1. It will won't cancel. 0, 0, 0, 25 fourths. That is 0.04. That is what we get. 4 into 10 power minus 3. This much water molar. So concentration of this urea will be 4 into 10 power minus 3 molar. Understood, students? So mole concept link up. See here molecules we have given, here we are converting the molecules into moles. So we bring molecules, given molecules into mole, divide with Avogadro number. Following students, this is what molarity. Copied all of it. Right. Now see next right heading, relation between, copied now, right. Next right heading, relation between. This is important in exam point of view. There is a relation between mass percentage, that is W by W, molarity and density. So this is important. In exam they give you mass percentage to you, density they give you, and they ask you to find molarity. In NCERT this type of questions, and even in JEE mains and NEET they are asking questions on this. See, density given, molarity they will ask mass percentage, and there is a relation, molarity is equal to mass percentage into 10 into density upon molar mass. This is the relation for molarity. Keep it in box. So when mass percentage is given, density is given, how do we get molarity? The percentage mass into 10 into density by molar mass. This is the relation from NCERT, and in exams they are asking questions, numericals on this. Write one question. Concentrated sulfuric acid, that is H2SO4, having mass percentage, having 98% W by W. What is W by W? Mass percentage. And its density is 1.8 gram per cc. Then find its molarity. Now see, in the question, when you read out the question, mass percentage given, density given, asking to molarity, then direct substitution. So what will be the molarity? Percentage has been given 98. So this 98 into 10 into density of the solution given 1.8 by molar mass. What is the molar mass of sulfuric acid? When you add algebraic sum 2 plus 32 plus 64, that comes 98. So 98 get cancelled. So 10 into 1.8 comes how much? 18. So answer will be 18 molar. Understood? Important model. Put star mark for this question. So sulfuric acid density, when they give you mass percentage they given, and they ask you find what? Molarity. Now think over, students, suppose we don't know about this formula, forget about formula, then without formula how do you approach? What does 98% W by W mean? I write here, say 98 grams sulfuric acid has been present in how many grams of solution? 100 grams of solution, no? Do you agree? So are you getting my point? 98% W by W means 98 grams sulfuric acid is present in 100 grams of solution. Clear? Now density given means something to do with density. What is density? Mass per unit volume. Density of the solution given to us 1.8. Mass of solution we know 100. And what is unknown? Volume of solution we have to find. Getting idea? Now from this obtain volume of solution. So volume of solution comes how much? 100 upon 1.8 in what unit? Milliliter. This is volume of solution we found. Are you getting idea? What I am doing is without formula, how this relation we got. Now molarity is nothing but mass. Do we know mass of solute? S 98. So I am putting 98. What is the molar mass of sulfuric acid? 98. Volume, this is the volume we got. See what I am writing here. This is ml, no? So 100 by 1.8. 1.8 goes to numerator. Into this volume ml I have to convert in liter. So I have to multiply with what? 1000. Now see, these two zeros get cancelled. Then do we get the same relation? Check. See, mass percentage we wrote as such 98 into 10. See, after simplifying this cancellation of two zeros, 1 point density 1.8 into 10 by molar mass. Are we getting the same answer? 98, 98 cancel. This comes 18 molar. Clear? Followed? So without formula, see the mass percentage given, that means 98 grams is present in 100 grams. Density given means what is density? Density is mass per unit volume. Density also given 1.8 and mass of solution is 100. Volume of solution we found here. This is 100 by 1.8 ml. Now molarity I substituted 98 by 98 into 1. This when we divide this 1.800. 1.8 goes to numerator into 1000. Finally, do we get the same relation or not? Percentage into 10 into density by molar mass. Understood? Copy this. You copy both the direct formula we can apply or you can do in this approach. In school point of view, competitive point of view, you can apply direct formula. But in subjective pattern, you have to show that how we got 18 molar. Shall I move to next? See. Next, see, we have to study dilution law. Right, heading dilution law. Dilution law. Now, what is meant by dilution? Important in exam. Dilution is no. Adding water is called dilution. Addition of water is called dilution. Right? That addition of water is a dilution. No, means when you add water, that is what we are doing dilution. No. Now, what is molarity, students? Molarity we learned just now. Molarity is given by number of moles by volume of solution in liter. Now see, when you add water on dilution, what will not change? See, number of moles of solute will won't change. Do you agree? On dilution, when you add water, initially how many moles of solute is there? After adding water also it remains same. Correct? That means number of moles of solute remains constant. There is no change in number of moles of solute. So make a note. In exam they give statement wise. On dilution, number of moles of solute remains constant. It will won't change, Then what we take M1, this is molarity into volume. So that means M into V remains, then we can write M1 V1 is equal to M2 V2. So for two solutions, this is the relation for dilution law, where M1 is initial molarity, V1 is the initial volume, M2 is the final molarity after adding water, V2 is the final volume. Write this initial molarity, this is initial volume, this is final molarity, and this is the final volume. So in exam point of view, they ask numerical on this, and during dilution, what will remain constant? Number of moles of solute remains constant. Understood, students? So this is important in exam point of view. They ask questions related with dilution law. Copy. Now write one question on this. Clear all of you? Now write one question. A decimolar, deci is what? 1 by 10, no? Or sometimes in textbooks they show like this, m by 10. A decimolar HCl solution What is HCl? Hydrochloric acid solution. Present in 200 ml solution. Present in 200 ml solution. Is diluted to 1 liter by adding water. Then find the final normality. Now question understood. Initially, what is the concentration of HCl? Decimolar. Deci means 0.1 molar. This decimolar is present in how many ml solution it is? 200 ml it is present. Now to this 200 ml of decimolar is adding water. Diluted with water means diluted. He has added water and he made it to 1 liter. See the units carefully. This is in milliliter. This is in liter. Then student, 1 liter he will be equal to how many milliliter? 1000 ml. So by adding water till 1 liter, what will be the final molarity is asking. Means what will be the, after adding water, what will be its final molarity. So direct we have to apply dilution of formula, that is initial molarity is 0.1 molar. Initial volume is to be 200 ml. And this is diluted to 1 liter. Means what you consider final volume? 1000 milliliter. Means additionally he has added what? 800 ml water to it. Correct? By adding 800 ml water, it has made to 1000 ml. Now what will be the final molarity is asking. Now direct substitution, apply this relation. M1V1 is equal to M2V2. M1 is 0.1 into this is 200. This should be equated with final molarity we have to find into 1000. Now these two zeros get cancelled. 0, 0. 2 will cancel by 5 times. Now when you bring that M2 comes how much? 0.1 upon 5. 1 upon 5 comes how much? 0.2. 0.2 into 0.1, final molarity will be 0.02 molar. This will be the final molarity. Initial molarity is to be this much. By dilution, what happened? Its concentration changed from 0.1 molar to 0.02 molar. Understood? This is dilution law. Clear, students? Are you following everyone? So simple. Copied all of it. And here decimolar means you have to know deci is 1 by 10. Or in sometimes they say m by 10. Now see, and another in the same dilution law, copied all of it. Now see, in the same dilution law, sometimes what they ask in the problem, how much volume is to be added, what amount of water you have to add to convert initial molarity to final volume. See, right here, volume of water to be added. To bring initial concentration to final concentration, then how we approach? You have to find first final volume using the dilution formula. Same M1V1 is equal to M2V2. After getting V2, you have to subtract the initial volume. So final volume after obtaining, you have to subtract from final volume initial volume. That will give what? Volume of water added. Now write one question related to volume of water added. See in exam how they ask a decimolar. Deci means how much, student? 0.1 molar. Present in 200 ml solution. is converted to centimolar. Centi means how much? 1 by 100. That is 0.01 molar on dilution. Then find the volume of water to be added. Question you understood previously what we asked, final molarity asked in the previous model problem. Final molarity asked. Now in the question what is asking, initial molarity is 0.1. This 0.1 which is present in 200 ml, by adding water it has converted to centimolar is saying. So to bring this 0.1 to 0.1 molar, how much additionally you have added water to 200 ml is asking. How much amount of water you have added to the 200 ml of solution is asking. Then you have to apply the relation dilution formula, that is just now what we wrote, M1V1 is equal to M2V2, where M1 is the initial molarity. What is the initial molarity given? 0.1. What is the initial volume given? 200. This is equated with, it has been converted to centimolar is saying. So centi is to be taken 0.01 into V2. Now obtain V2. V2 comes how much? 0.1 into 200 by 0.01. Means I can cancel this. This will be 10 power minus 1 now students. This is 10 power minus 2. This 10 power minus 2 when you bring numerator that makes 10 power 2. And from 10 power 2, 10 power minus 1 cancel. That comes to 2000 milliliter. Check whether you are getting 2000 milliliter or not. On simplifying, I am getting 2000 milliliter. You people also check. But this is not our answer. What he wants to, what he is asking to this, to bring this 0.1 molar into 0.01 molar, how much additional water you have added to this 200 ml is asking. Are you getting my point? Now this final volume what we got, that is 2000. From that many students will forget about subtracting this. This 200 we have to subtract. No, to get what volume additionally we have added. That comes how much? 1800 in what unit students? Milliliter we get. So this should be the answer. Suppose if option would have been given in liter, examiner wish he can ask in liter, milliliter. So if the same question would have been given in liter, what we do? We divide with 1000, no? So when you divide with 1000, the answer should be 1.8 liter. If it is in SI unit, 1.8 liter. If it is in CGS, we have to write as 1800 milliliter. So understood, this is what important. What volume of water means to bring the initial concentration to final concentration. Additionally, how much water we have added. So to bring additional how much amount of water added, what we do? First find out the final volume. After getting final volume, subtract the initial volume. They are following students. This is what dilution law. In dilution law, two ways they ask. Final molarity they can ask, or how much water we have to add. Clear students? Right. Next write heading, copied all of you. Clear now? Now write next heading. This relation you keep it in box. V2 final volume minus initial volume. Now write next concept, mixing, right? Mixing. See in exam what is mixing? We add two acids with each other or we add two bases with each other. That means acid is mixed with acid or base is mixed with base, but not acid with base students. either acid with acid or base with base, two non-reacting. So write one question, suppose write one question, a 0.1 molar HCl, that is decimolar HCl, present in 200 ml solution, is mixed with 0.5 molar, that is semimolar HCl, present in 300 ml solution. Then find its resultant molarity. The question you understood, two acids he took. What are the two acids, students? One of HCl and another also HCl. What is the initial molarity of the first HCl? 0.1 molar. Of how many ml it is? 200 ml. Second acid of how much concentration? 0.5 molar. Of how much volume? 300 ml. So both these acids, what he is doing, he is mixing. So when you mix the two acids, the resultant molarity is given by M1V1, as it is M1V1 plus M2V2. Volume of the solution gets additive. That means V1 plus V2. Since volume is additive. So this is the relation when two substances of non-reacting are mixed with each other, where M1 is the initial molarity, initial volume, final molarity, final volume by total volume. Now direct substitution, what is the initial molarity? 0.1 into 200 plus 0.5 into 300. What is the total volume? Volume is that 200 plus 300. Getting idea all of you? This comes how much? 200 into 0.1 will give number of millimoles. That is 20. 20 plus this comes how much? 300 into 0.5. It means half of 300. 150. This is divided by 500. So 150 plus 20 comes how much? 170. Now I write here 170. So molarity of the resultant solution will be 170 upon 500. This 0 get cancelled. Divide 17 upon 50. That will give in terms of molarity. Understood? So when two similar substances are mixed with each other, resultant molarity, how do we get? M1 V1 plus M2 V2 by V1 plus V2. Here volume is of the solution comes additive, no? So V1 plus V2 in the denominator. Clear? Copied all of you, understood, no? So final molarity will be 17 upon 50. If option is given with 17 by 50, you have to opt that, or you have to simplify this. Do simplification of 17 upon 50. Unit will be what? Capital M. So with this molarity completed. Now write next relation between molarity density. There is a relation between, relation between molality. What is molality? We already did, no? Small m. And molarity. What is molarity? Capital M. And density. So in exam JEE Mains as well as NEET, we get questions on molarity, density. In the problem, they give you density to you, molarity to you, and they will ask you to find molarity. See, there is a relation between these three. Write this relation. Molality is equal to 1000 into molarity by 1000 into density minus molarity into molar mass. This is the relation between molality, and density. So in the problem, molarity will be given, density will be given, and they will ask you to find molality. Molar mass we can find from the substance. Copied all of it. Now write one question. Here I write that question. See, concentrated sulfuric acid having 18 molar. What is the molarity of that acid? 18 molar. Molarity of sulfuric acid given 18, and its density is 1.8 gram per cc. Then find its molarity. So questions are, in this question he has given molarity to you, density to you, and he is asking to find molality. Sorry, this is to be taken molality, small m. Understood, student? So this is we have to find. Now substitute in this relation. So molality is equal to 1000 into, what is the molarity given in the problem? 18 molar. Right here 18 by 1000 into, what is the density of the solution given? 1.8 given density into 1.8 minus molarity of the sulfuric acid that has given 18 into, what is the molar mass for what? Sulfuric acid. Sulfuric acid, you know, 2 plus 32 plus 64, that comes 98. Now this numerator, how much it comes? 1000 into 18, that comes 18,000 by this 1.8 into 1000, 10 get cancelled, no, 1800. This is 1800, and multiply 18 with 98 in the rough work. 18 98s are 8 8s are 64, 8 plus 6 14, 72, 9 16. Is it coming 1764? Checked by your side. This is 1764. Now from 1800 subtract 1764. So from 1800 when we subtract 1764, 10 minus 4 comes 6, 9 minus 6 3. That is coming 36. So in the denominator I place here 36. Getting idea all of you? So here I am writing one more step, 18,000 by 36. Now 18 multiple will cancel by 36 by 2 times. 18 ones are, this is 1000, 18 twos are, 2 will cancel 1000 by 500. So final answer will be 500 molal. This is what molal. Molal means molality. Understood? This is the final answer, 500 molal. Copy it. So in problem, when they give molarity, density, asking to find molality, this is the relation, or without relation also you think over how you do. Now I don't know about this relation. Now students, I write here how we approach this relation. See. Now see in the problem, he has given molarity given, and what we want, density given. Density is nothing. What is density, student? Density is mass per unit volume, no? mass per unit volume. So density of solution, how much he has given? 1.8. Do we know mass of solution here? Mass of solution 18. What does 18 molar means? 18 molar means 18 moles is present in how many ml of solution, students? 1000 ml of solution. No, do you agree, all of you following what I am saying? 18 molar means this 18 moles is present in 1000 cc, no? So means what I am finding, mass of solution we are finding. This is 1000. Getting idea? So density I wrote 1.8, mass of solution, by volume we know 1000. From this what will be mass of solution? That is 1800 grams we got. Correct? Now molality, to get what we require, weight of solvent we require, no? To bring molality what we require, weight of solvent. Then weight of solvent, how do we get? From this 1800 subtract mass of solute. That means 18 moles means how many mole? 1 mole weighs 98. So 18 moles will weigh how many grams? 18 into 98. That is the same weight we took, see, 1764. So is it coming 1800 minus 1764? 36 grams is the mass of whom? Solvent. Getting idea? We found mass of solvent. Now molality is nothing but number of moles. No, number of moles is 18. Weight of solvent we found 36. But this 36 in grams. So I have to divide with 1000. So this will cancel. 18 ones are, 18 twos are, 18 twos are. This will cancel by 2 by 500. Are we getting the same answer, 500 molal or not, students? See, without the relation of this formula, what we found? Density. From this density we found mass of solution. Mass of solution, after getting, what we do? We have to subtract the mass of solute. What for? Since in molality we require whom? Weight of solvent. So weight of solvent, how do we get? From the solution mass, subtract the mass of solute. How you get mass of solute? As you know, 1 mole will weigh 98 grams. So 18 moles, to get more mass, what I do? 18 into 98, that is 1764. Subtracting we get 36. Moles I wrote as such 18 by 36 into 1000. Answer comes to be same as 500 molal. Clear, understood this one? So this is what relation between molality, molarity and density. In exam they are asking questions related with relation between molality, molarity and density. Clear, students? Are you following, everyone? And see, I told you in the day one itself, on the day what I teach, that you have to recap at home and the hostel, as you are in hostel. So day wise what we teach here, you have to recap and you have to interact with the teacher. So on the day wise doubts what you are having, clarify it, so that that makes easy for you. You won't feel burden, because you will be having later weekly test, fortnight test, and what else the test we are conducting here, all India test series. In that all those tests, if you want, if you to get good score, so from day one onwards more practice you have to do. Chemistry is a scoring subject, so understanding, and you have to put on practice daily. 20 to 25 questions you have to solve. 2 hours you allot for chemistry. So from day one onwards, be serious. This year everyone should get good score, good rank in JEE mains as well as in NEET. So prepare well, and we will interact on June 1st onwards physically. So copy them all of you this one. So this is what relation between molality, molarity and density. So we will conclude here. I will stop this. Tomorrow we will discuss ppm, parts per million, and after that we go into solubility. Okay, students. Right. I'm ending the session. Bye.